Hello and welcome to the PowerPoint presentation of my senior capstone design thesis project, design of an omnidirectional light bar. The first step to this project was the solution approach, which consisted of 5 steps. First was research. The intent of this first step of the project is to research lighting methods that are currently employed in passenger vehicles, investigate other materials used, and see how driver visibility affects driving habits and reactions. The second step, concept design, was intended to determine all the requirements for the project and product lifestyle, taking lessons learned from that research to determine what is needed to make a competitive design. The third step, CAD design, the intent was to use SolidWorks to create a detailed 3D design that accurately conveys specifications and shape of the light bar, making it easy to understand to outsiders. The fourth step, stress analysis, was intended to utilize the same program to evaluate the design under stress and perform failure analysis to ensure that a safe design has been made and that will hold up to outside stresses. The fifth step, cost analysis, was intended to utilize the modeling program to evaluate the product design in terms of cost to produce and possible environmental costs. The research, while scant in terms of technical papers written based on actual light bars and their recreational off-road use in overlanding situations, proved useful to show that vehicles were already using for lights and materials, as well as how light affects driving. The research suggested that LEDs had become more prominent in vehicle lighting, and the light bars were used a mixture of floodlight style lights and spotlight style lights as to provide a mixture of a wide field of view and long sight range. The research also showed that a majority of the construction materials in vehicles is steel and aluminum, which help whittle down material choices for the light bar. Finally, the research showed that animal collisions were decreased as well as driving habits were bettered when there was more light present. The concept design was narrowed down by 3 decisions. The first decision was to use the greatest number of existing parts as possible, which in turn determined a lot of the dimensions of the rest of the design, as the new parts would have to work with existing parts. The second decision was to have the light bar designed to be easily manufacturing, meaning parts will be kept simple to prevent the need for complex fixtures or jigs. Final decision was to design for easy assembly, meaning that the product will be easy to put together not only by employees but also by consumers. The other considerations for this design were that it was ensured to fit a wide range of vehicles. Moving on to the CAD design. The top left corner shows the final rendering of the project with its aluminum rails, lifters, rollers, and light bar. The top right-hand corner shows a close-up of the interior brackets of the rails, as well as you can see the T-slot nuts, the lifters, and the heatsink on the back of the light bar. The bottom left-hand corner shows the front view of the lifters, as well as the aluminum blocks that joined the rails together and allowed for the rollers to pass through. The bottom right-hand corner shows the roller, nut, and bolt assembly that lifted and locked into place, allowing for the light bar to roll around through the aluminum rails and then lock into place when the desired place was reached. The stress analysis was done to determine the effects of greater than usual forces on these pieces. I was looking for von Mises stresses, and as you can see in this figure right here on the left-hand corner and left-hand side, that the stresses that it was built well, but the stresses deformed the inner part of it. However, that will not really be experienced in actuality, as it would be as if you were pushing the light bar over. In the top right-hand corner, there was deformation to the lifter, as it took quite a significant amount of force to. If it took quite a significant amount of force to press down on the lifter, you could deform the bracket, and that can be fixed by, instead of making the bracket out of sheet aluminum, making it out of sheet steel. And on the bottom right-hand corner, there is the bracket for the light bar, which is a standard part. However, I still wanted to show if the deformation, if something like a tree hit the light bar. It is pretty significant. Then there's the cost analysis. Costs were determined for the manufactured products, and the standard prices were determined for bought parts, and that all totaled $247.78 US. However, an additional $100 should be tacked onto this price, as it does not factor in the cost of the light bar. And also, what is not taken into effect is the work for the mounting bracket to the vehicle. This is meant to be distributed and made in the US, and altogether the design weighs about 13.24 pounds and is built to last 7 years, which is the typical ownership period of a car. Here is the breakdown of the environmental impact. As you can see, the majority of it is in material processing. Only a little bit is manufacturing, but it is still good, viable design. And with that, that brings us to the end of this presentation. I hope you have a wonderful day. Bye.